and it is a little bit overwhelming. But when you have a question like this, that yes, it has a lot of words and it's a little bit overwhelming, a nice starting place is to draw a picture, draw a diagram, give yourself some sort of sense of what are we trying to solve for here. So we've got the Earth. You know, if you want to avoid doing the question for a little bit, you can like try to draw North and South America here or something like that. And have some fun. That's not, oh, it should be a little wide. There we go. There we go. Perfect planet drawn there. And what we have is a space station. So here, what do space stations look like? They must look like this, little bugs. Perfect. And that space station is 400 kilometers above the Earth's atmosphere, and the radius of the Earth is 6,400 kilometers. So if we went right from the center, this part would be 6,400, and this would be another 400. And so this whole thing would be 6,800. And this space station is orbiting, so it also is going around in a circle. And we know that it's traveling fairly fast, 27,600 kilometers per hour. So now it travels 40 minutes. So the first thing we're dealing with here is its speed is per hour, and we travel in minutes. Will it go more than 27,600 kilometers in 40 minutes or less than 27,600? Less, because that's the amount it goes in an hour. So we need to find out how far does it travel. Let's say that's 40 minutes. How far does it travel in that 40 minutes? How do I figure that out as a starting point? In 40 minutes.
So you start by calculating the circumference of its orbit.
So you want to figure out the whole circumference here, okay?
Yeah, and then figure out how much 40 minutes is from that.
Okay, but how would 40 minutes be related to the circumference?
Well, the circumference is your distance.
Yeah, that would be the distance all the way around.
So you can do V equals D over T to find.
Oh, so you're using a physics formula?
Yeah.
Okay, but if we're using a physics formula, that only helps the people that have been in physics, and it's not going to help. How many people are not in physics? Okay, so maybe you just fail this course as well then? No, that's not fair. We have to be able to use our mathematics, so we're not going to use a physics formula.
Here to learn math.
Yes?
You multiply how far it is going by how many kilometers an hour it's going by how many.
So you're taking the 27,600, how many kilometers an hour it's going?
And then multiplying that by 40.
Multiply it by 40/60ths, or 2/3. Because if we look at a ratio, our 40 minutes is less than an hour, right? And if we look at what proportion of an hour that would be, 40 out of 60 would be the proportion of the hour that you're traveling. So when we multiply those together, 27,600 times 2/3, we find out that in the 40 minutes we've traveled 18,400 kilometers. So I can label that, that's this red line. That's how far it's traveled. And if we join that new point to the center as well, this question is asking to the nearest tenth of a radian through what angle? So in other words, what is this angle that our space station has rotated? Well, drawing the diagram is nice because when we look at our diagram, we realize that we have an arc length problem here. But we know the arc length. What we don't know is the angle. And on your formula sheet, you have the arc length formula. It's in its simplified form. S equals theta times the radius. And this formula only works when it's in radians. A reminder, how did we find that formula? That formula we found because whatever our angle is, it's a proportion of the whole way around. And all the way around was 2 pi. And that proportion is how much of the actual circumference we'll have. Now the reason it's in this other form on our formula sheet because it's so easy to simplify. We simplified those 2 pi's and it just becomes theta times r. Now in this question, what do we know? We know what the arc length is. We know that the arc length is 18,400. We want to find out what theta is, but we also know that the radius is 6,800. So if we take 18,400, divide it by 6,800, we find out that theta is equal to 2.7 radians. So since we use the formula in radians, when we solve for theta, our answer is going to be in radians. Part B, oh, I haven't done part B yet. Part B down here. Now it's asking, how far did that space station travel if it just went straight there? If you started from here and you went straight here, how far a distance would that be? Well, again, the diagram, we're going to look at this. We're going to assess what we know and see if something comes up for figuring this out. Yes? So the 6,800 comes from the radius because we know the radius of the Earth is 6,400. So the 6,400 would be only up to there. And then the space station is another 400 above the Earth. And so now if we look at the orbit or the circle that's made by the space station, its radius is going to be the 6,400 plus the 400. So if we look at what we know in this new question to find that purple line, we know the angle now because we figured that out in the part before to be 2.7. We know that this length is 6,800 and this length over here is 6,800. And we have a triangle. So the next thing I would do is I'd say to myself, if I just look at that triangle, 2.7 radians here, 6,800 here, 6,800 here. Is there something I've learned from previous math that would let me solve this? Do I have stuff in my triangle repertoire? Can I use SOHCAHTOA? When am I allowed to use SOHCAHTOA? Right angle triangle. Is 2.7 make it a right angle triangle? No. So I can't use sine, cosine, tan in SOHCAHTOA because that's only good with a right angle triangle. I can't do a squared plus b squared equals c squared because that also only works with a right angle triangle. What else do we know about solving triangles? There's the sine law and the cosine law. So now let's see if we can remember. Is this one of those situations? And which one would we use, the sine law or the cosine law? And how do you remember which one to use? It's going to be the cosine law. How do you remember how to use? Okay, so either you've separated that the cosine law is in two different cases that you use it, either when you have all three sides or two sides and the angle between them. Good. Anybody else have other ways that they remember when to use sine law or cosine law? Just memorize which cases. Okay. I like, for the sine law, what do you need for the sine law? You need an angle and an opposite side. So for myself, I always look, do I have an angle and its opposite side? In this case, I want to find out, this was the purple length on our page, I want to find that out. I don't know an angle and its opposite side. I know the 2.7, I don't know its opposite side. I know the 6,800, I don't know the angle. And so we can't use the sine law here with the information that we have because we don't have an angle in opposite side. I always look for the sine law first because I find it's a little bit shorter than the cosine law, but in this case we're going to have to use the cosine law. So you don't remember your cosine law most likely. I'll show it to you again. On your formula sheet last year it would have been written like this: a squared equals b squared plus c squared minus 2bc, bc times cos of angle A. What does that mean? As far as that formula, if you see that formula on a formula sheet, whatever angle you know goes with the opposite side on the other side. So we want to find x, and we know the angle opposite it. So when we write this out, we'll have x squared equals 6800 squared plus 6800 squared minus 2 times 6800 times 6800 times cos of 2.7. Now a couple things when I go to put this into my calculator. First of all, the last thing we calculated, I'm just going to put it in here as well, was the 18,400 divided by 6,800. That was the last thing we calculated to get our 2.7. That's going to be important because we're going to need to use that answer in this question. Now, when I'm typing this in, everything on the right side of my equation is written out. So I can type in that all at once. 6,800 squared plus 6,800 squared minus 2 times 6,800 times 6,800 times cos of, now instead of using 2.7, because that would be rounding early, we want to use our exact answers while we're doing all of our calculations. So I'm going to go second answer because it's going to take my answer from above and put it right in there. What I get is an answer here, which is 176 billion. We have to remember that that is equal to x squared. Our x squared is 176 billion 319,638. Dot, dot, dot. Now to find out what x is, find out that actual length, we're going to square root our answer. And we find out x is 13278. The question says round to the nearest 100 kilometers. So the nearest 100 kilometers, 300 rather than 200, 13,300 kilometers. So it would have been a lot shorter for that space station if we go back to original picture, if it had decided to travel straight across rather than do its actual orbit. However, there might be like mountains right here, the Rocky Mountains, and then that would be bad. Also, it's easy to have something in orbit rather than forcing it to go in a straight line like that. And it's traveling pretty fast as it is already. The answer to B is 13,300 kilometers. So if you really, really enjoyed that word problem, there are two more that you can practice.